Hey guys, here's the notes for 7-8, curve fitting with exponential and logarithmic models. Hopefully you remember back in Algebra 2a, we did curve fitting with various functions, linear functions, quadratic functions, I think even cubic functions. And basically what we did was we used our calculator and entered some data into the calculator in list 1 and list 2 and tried to find the model or line or curve of best fit. Well, you can do that too with exponential and logs, but we're not going to look for differences, at least not when we do them. We're going to look for ratios. So what I mean is this: if you first have to check to see if you have a common difference. So you check your x values, make sure they're increasing at a constant rate. In this data set down here, the x's are all going up by 1, starting at -1. Then you're going to next find your differences. Hopefully you remember this. If your first differences are not the same, then we're going to check the ratios of those differences. And if those ratios are constant, then what we have is an exponential function. So what I mean is, if we look at this example here, the x's are going up at a constant rate. It's just +1, +1, +1, and +1. So then we look at the differences between the y's. 3 minus 2.2, and 7 minus 0.3, and 27 minus 7, and 127 minus 27. And we get this: 0.8, 4, 20, and 100. If these were all the same, we'd have a linear function. We don't, and they're very far apart still. So what I'm going to then look at is the ratios. What's the ratio of 4 to 0.8? It's 5. 20 to 4, 5. 5, 100 to 20, 5. So the common difference, or I should say common ratio, is 5. So this is exponential. So we can say it's an exponential function, and then I'll show you in a moment how you can figure out what that exponential function actually is. Now, if we look at the second data set, first of all, our x's are going up by 1 every time. 1, 1, 1, 1, same thing. We're looking at our differences here, and if you look, they're all what? They're all 3. So this is not exponential, and in fact, like I told you before, it is linear because our first differences are constant. So let's take a look at this table here. We've got our x's going up by 1. We're going to look at our differences. 1.5 minus 3.75, or 0.75, I should say, 0.375. And then I'm going to do 6 minus 1.5. So we got 1.125, and there's the bell, right on time. Okay, then we got 4.5, 24 minus 6, that is 18. And then 96 minus 24 is 96 minus 24 is 72. So notice we're going from 1.125 all the way to 72. So I'm going to look at my ratios. What is 4.5 divided by 1.125? That is 4. What is 18 divided by 4.5? That is also 4. And I'm going to take a wild guess and say that 72 divided by 18 is 4. Let me verify that with a calculator just to be sure. It's 4. So this is exponential, and the common ratio is 4. Let's take a look at number 2. The first difference is 17 minus 9. 17 minus 9 is 8. 41 minus 17 is 24. 113 minus 41. $72. And 329 minus 113. That is 216. All right, now here's a big hint. Look at how quickly these numbers are going up. We're going from 9 to 329, and basically we went from -1 to 3. We went 1, 2, 3, 4 spaces. So there's a big hint that these numbers growing so quickly, so fast, it's probably going to be exponential, but we have to be sure. So now let's take a look. 24 over 8, that is 3. 72 over 24, that is also 3. And guess what? 216 divided by 72, you know what that is? That's 3. So this is exponential, and our common ratio is 3. So now, like I said earlier, how do we figure out what this data is? Well, there is a way to do this on your calculator doing what's called exponential regression. Most graphic calculators have it. The TI-84s definitely have it. If you don't have a graphic calculator with you, don't worry. I'm going to show you a way you can do it without it. This data in the table below can be modeled as an exponential function. Now, that's the important thing. They already said it's exponential. So we don't have to go through the check that we did on the first page in the notes. We just have to assume, because they said it was exponential, that it is. So what we're going to do is, on our calculator, we're going to do this. You're going to go to Stat and Calc. But before that, we're going to do this. They say to enter your lists L1 and L2. I'm going to do this. I'm going to do Stat and then Edit. And you're going to put everything in the first column or first row is L1. All of these guys are going to be L2. And then you're going to do Stat Calc, and you're going to do this guy here, exponential regression. And if you do that, it will figure out what the best model would be. You'll see y equals a times b to the x. They'll say a is 118 point whatever, b is 1.75 whatever. Your r squared value, if you've got diagnostics on, is going to be 0.99. It's pretty good. So this is definitely going to be exponential. The closer this value here is to 1, the closer it is to 1, the more likely it is going to be exponential. Now you can also do logarithmic regressions and natural log regressions, I believe. You can definitely do natural log, but we'll talk about that at another time. So the number of bacteria based on this table, it can be modeled by this function here. So it grows by about 75% every time period. So now if I want to figure out what they want to know, oh yeah, when is it going to be up to 3,700? You can do that trace function, and you can follow these directions, and you can figure that out. It'll take about 6.17 minutes. All right, so let's see. We'll do this on the calculator first, and then I'll show you. Actually, you know what? I'm going to show you the other method first. You don't have a graphic calculator at home, this is what you're going to do. And I'm going to put this link into the folder. But if you go to this site, Keynesian Online Calculator, I'll give you the link, but it's Keynesian at Keynesian.casio.com. If you notice here, they've got all these different types of regressions. Logarithmic regressions, exponential regression, which is that natural log, the e to the x. And they got this, AB exponential. You tap on that guy, and then you've got a table here. And they've got some values already pre-generated. If you want to figure out if this is in fact an exponential equation, you just enter the numbers in the table, you hit execute, and if you scroll down a bit, it does the same thing. We're basically looking at the values down here where it's the correlation coefficient of R and then A and B. And yeah, is it exponential? Well, 0.78, probably not. But if we now want to go back and enter these numbers in, 0 through 5 for X. So I'm going to, hold on, I'm trying to go there. I'm going to put in 1, or what was it? 0, 1, 2, 3, 4, 5. And this is just a little JavaScript program. Delete these other ones because they will mess up our data. And then we're going to enter the Y values, 250, 360. Bear with me, it's my first time. 250, 360, 45, 686. 6, and then the last two are 964 and 1348. 964, 1348. Just delete the rest. And then when I calculate these, here we go. My correlation coefficient now is about 9.998. That's pretty good. My A value is about 251.9, and my B value is about, well, I'll say 1.4. So then what I could do is, back there, what did we say it was? Sorry, 251.9. So I'll say B is about 252 times 1.4 to the T. So if I want to know when is this going to reach 1800, I could then graph this and figure it out. Or, you know what, I could just try some numbers, plug them in, and see what I can see how far this is going to go. Yeah, this is going to be a lot easier if you have a graphic calculator at home, but you can always go to this website and have it calculate this stuff for you. If I'm looking at here, 1800, it looks like it's going to be right around 5.7, maybe? I don't know. But anyway, this is a nice little online regression calculator for you. If you want to look at another one that you think might be better, just look for exponential regression functions, which is what we're doing here. I'll write this down. Look for exponential regression. And you want it to be AB to the X, as opposed to E to the X, which is a natural number, E. All right, so there it is. If you have questions, let me know. I know this is going to be a little tricky without a calculator with you, but I think you guys can manage.